And now we're going to look at the definition of a probability tree diagram. A probability tree diagram is a special type of graph that's used to represent outcomes of an experiment. A probability tree diagram is better than a Venn diagram to represent two or more probabilities of either the same sample space or different sample spaces. Probability tree diagrams consists of events connected by branches in a tree-like structure. The example below has 3 coin flips, and each coin flip kind of demarcates a horizontal forking of levels. So let's take a look at this example. So to me, these probability tree diagrams look less like trees and more like the path of a lightning bolt kind of coming down from a cloud down to objects on the ground. So that's the visual that I've created here. And we're going to be looking at flipping a coin, starting with a first coin flip. And so we're going to define event H to be the event of flipping a heads on the coin, and event T to be the event of getting a tails on a coin flip. And so you can see here at our first coin flip, we can get heads or we can get tails. Now on our second coin flip, our second experiment, if we had flipped the coin and gotten heads on the first coin flip, then on the second coin flip, we could have either gotten heads or tails. So the outcomes that we could get on the second coin flip are not dependent on the results of the first coin flip. So this is kind of where coin flipping is an example of an independent set of events, because the outcome of a second event isn't dependent on the outcome of the first. Anyway, let's continue. So we flip the coin twice, and let's say we go to flip the coin a third time. And so if the first coin flip had resulted in a heads, the second coin flip had also resulted in a heads, then on the third coin flip, we could have gotten either heads or tails. So that's kind of how you can kind of trace the history of multiple coin flips and kind of chain them together. So for example, if the first coin flip had been heads, the second coin flip had also been heads, but then the third coin flip had been tails, then we would have taken this path all the way down to the ground. And likewise, if the first result had been heads, and maybe the second coin flip had been tails, then the third coin flip could either be heads or tails. And if the first coin flip had been tails, then the second coin flip could have been heads or tails. And then we would also have the same outcome possibilities for the second being heads. We could get heads or tails. Or after the second coin flip being tails, we could have gotten heads or tails again on the third coin flip. So this is actually kind of a map of the potential outcome history of doing 3 experiments, of doing 3 coin flips, and them coming out, the result coming out to being heads or tails. So let's kind of see how that translates down below to kind of get a sense of how this relates to probability. So let's say we're going to look at the outcomes of 3 coin flips where tails occurs just one time. And so in 3 coin flips, we could have heads, heads, tails that has only one tail occurring. We could have heads, tails, heads, and that would be tails occurring only once. Or we could have tails, head, head. And let's see where those are kind of on our tree diagram. So we could have had heads in the first coin flip, heads in the second coin flip, but then tails in the third. So this option right here is heads, heads, tails. And let's see, how about heads, tails, heads? So again, that would have been heads in the first coin flip, tails in the second coin flip, and then heads in the third coin flip. And then lastly, we could have gotten tails, heads, heads. And so that means the first coin flip was a tail, the second coin flip was a head, and the third coin flip was a head. So I've kind of put an icon of a barn to kind of represent each path that results in only one tail occurring. Okay, so let's look at maybe this event where tails occurs 2 times. So we've got heads, tails, 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 head, tails, and tails, tails, heads. So let's see if this doesn't get too confusing with this many colors. So we could have had heads, tails, and then tails again. Could have had tails, heads, tails. Or we could have had tails, tails, heads. So again, I've kind of put the pathing of 2 tails occurring in 3 coin flips with this little icon of a tree. And then we could look at 2 final combinations. One combination is where tails occurs 3 times. So tails, tails, tails. So that would have been tails, tails, tails to this outcome. And then finally, we could have had where tails occurs 0 times. So that means we would have 3 heads. And starting from the first coin flip, that would have been heads, 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 down to there. So a tree diagram is useful for kind of mapping out all the possible outcomes given events that can occur in one experiment, but tracking that history over multiple experiments.